My name is Petr Nevřela. I am a lead exterior lighting designer at ŠKODA Design. Together with my colleagues, we were working on exterior lighting of ŠKODA ENYAQ. And you can see that it is full of design innovations. Everything starts with the overall expression. You can have a look how the car is nicely focused to the front. Inside of the headlamp, we have new generation of the modules with hexagonal appearance and equipped by second generation of metric system with 24 segments. The signature from the headlamps leads to the center part of the car, and it's for the first time when we have our illuminated central mask. We call it crystal face. It's for the first time when we brought the theme from the show cars to the series production. Everything is connected with the horizontal stripe and making the car very wide looking and dominant. You can see that this expressive part is something really unique, which you will easily recognize every time you meet it. All these new innovative features are perfectly fitting to our first fully electric car, ŠKODA ENYAQ, and I'm sure you will like it.
Hello, my name is Oldřich Viziblo. In development of ŠKODA Auto, I'm responsible for electric powertrain. Now I want to show you powertrain of our ŠKODA ENYAQ iV. What is characteristic for this car is main powertrain on the rear axle drive, and in case of all-wheel drive car, the second powertrain on the front axle. Now, a little bit more to the rear axle drive. There is electric motor. In this case, is synchron electric motor with permanent magnets, which is connected to single-speed gearbox and controlled by power electronic. On the rear of the car, we can find some other components which are necessary for function, like the DC-DC converter to 12 volt, an onboard charger, so we can charge the car from home socket. All of these components are connected to power line and cooling system, which is included to the chassis and stay like the part of the car. On the front axle, we can find for all-wheel drive version second powertrain. In this case, it's asynchron motor, which is connected to single-speed gearbox and power electronic. On the front of the car, we can find some other components which are necessary for comfort, like the climate compressor and heating system. All of this is connected to power line, cooling system, including chiller. These parts are assembled to the chassis and stay like the part of the car. Maybe you have a question, why synchron machine and asynchron machine in combination? Synchron machine on the rear axle drive combined optimum power and efficiency, and asynchron machine for all-wheel drive version bring more power on the front axle. About the power, we start at 109 kW up to 195 kW for all-wheel drive version. Maximum power 220 kW is reserved for our RS version. Thank you for your attention and enjoy your drive.
Hello, my name is Katrin Oppenheimer and I'm a member of the team which develops traction battery in ŠKODA Auto. Let's take a look at one of the key components of our new car, the fully electric SKODA ENYAQ. Let me introduce you to the topic of the traction battery. This car with a beautiful crystalline design is really beautiful on the outside, but also highly sophisticated on the inside. ENYAQ iV is built on the modular electric drive matrix MEB. Volkswagen Group has developed it directly for electric vehicles. The traction battery has become a part of the chassis, which is designed to combine the perfect driving characteristics, requirements, special for an electric vehicle like safety, the largest possible battery capacity and many other parameters. The traction battery is used to drive car and, simply said, we use it instead of when I compare with normal combustion car. Sometimes it is used also the term high voltage battery. Our traction batteries in ŠKODA EV cars are currently based on lithium-ion technology. Volkswagen Group has its own research and development center for this key part, called the Center of Excellence, which is in Germany. We can choose more than design elements, colors and equipment in the configurator. We can choose from 3 different traction battery capacities. Let's start with the biggest one. Its nominal capacity is 82 kWh, of which the usable capacity for driving only is 77 kWh. This traction battery is made of 12 modules. Each module contains 24 cells. Other battery capacities and our options are 62 kWh, where the usable driving capacity is 58 kWh, and the battery with the smallest but still large capacity is 55 kWh, when the usable driving capacity is 52 kWh. Just to give you an idea, with the smallest battery capacity we drive more than 350 km per one charge. With the largest one, we can drive 520 km or more. These values are measured according to the global harmonized standard WLTP, thanks to which we can clearly compare the range of all cars between each other. Depending on the driving style, terrain and other parameters, we can drive much more on one charge. Let's now focus on the architecture of the traction battery. The housing light covers the battery and is also designed as a mechanical protection against contamination. We also see orange high voltage cables, which are used as a connection between modules containing lithium-ion cells and between the power electronics. The battery electronics collect and analyze signals from the battery and respond to them, as well as to ensure communication between the traction battery and the car or other control units in the car. On the right side, we see modules which contain lithium-ion cells. To give you an idea, the module size is 59 by circa 23 by 11 centimeters and weighs a little bit over 31 kilograms. The battery with the largest capacity, 82 kWh, contains 12 modules. We can see the size of the battery on this picture. The whole battery system weighs 493 kilograms.